All right, Algebra 1, here we are in section 1.3. We're going to talk about open sentences today. Let's take a look at some vocabulary. Our vocabulary list today looks kind of long, but it's not that big of a deal. It's not that long at all. So today we're going to talk about open sentences, and basically an open sentence is any mathematical statement, right, that has a variable in it. So 2x minus 3 equals 4, or 2xy equals 1. Anything like this, any kind of a mathematical statement with one or more variables is considered an open sentence. When you solve an open sentence, or the process of solving an open sentence really is the process of figuring out what the value of the variable is or could be, what values the variable could have. And so for this problem here, for instance, we would be looking for a value, some x value, that when I multiply it by 2, then subtract 3 from it, I end up with 4. Can you think of a number that would do that? If I take the number, multiply that number by 2, then from there subtract 3, I'd get 4. Take a moment to think, and I'll give you the answer. If you came up with the fact that x is equal to 3.5 or 3.5, you're correct. If you thought about this and you started putting numbers in there and you were guessing and checking, that was your process for solving the open sentence. If you have some skills with algebra and you were adding 3 to both sides and doing some manipulation, that is your process of solving an open sentence. And if you didn't get the answer at all, don't worry about it. We're totally going to be talking about this very soon. So what we found when we figured out the value of x was the solution to that open sentence. The next term that we need to discuss is an equation. An equation is specifically referring to algebra sentences that have an equal sign in them. So if you've got an equal sign in an algebra sentence like we do here, these are considered equations. Sometimes in math, when you have an equation, you might have something called a replacement set. Now, a replacement set refers to numbers that I would have, that I would use to replace the variable. So a replacement set would be a set of numbers used to replace the variable. So an example would be, let's say I had an equation 4x plus 2 is equal to 12, and I want to use a replacement set, a set of values that could possibly work as an answer for x, and I'm going to let that set be 0, 1, 2, 3, and 4. These numbers are going to be used to replace x to determine whether or not any element or value in this set actually, satisfies this equation or is a solution for this equation. So we've already kind of talked about replacement set, yet we have this word set. Set is basically just a collection of numbers or objects or letters, a collection of things. This collection or group of objects or numbers is usually bracketed off in this way. You'll usually see curly brackets on either side. When we talk about a set, we could have a set that looks like this. Usually sets have a capital letter as its name, so I'm going to call this set A. Let's say set A is the set of numbers 1/2, 3/4, and 5/6. All right, so let's say set A is the set of these particular numbers. One element of the set would be 1/2. So 1/2 would be considered an element of set A. And next we have a solution set. So a solution set would be the set of all answers that work in a given open sentence. So the set of all answers or solutions that makes an open sentence true or right or correct is considered the solution set. And finally, we have inequalities. Inequalities are comparisons of numbers or expressions. So an inequality is going to be a comparison of mathematical expressions using this, the less than or equal to, the greater than or equal to, the less than, the greater than, or the simply not equal to symbol. So when we use these symbols as opposed to the equation, when we use this symbol here, the equal sign, an inequality uses these symbols. And with that in mind, I think this would be a great time to start some example problems. So here we're going to use a replacement set to solve an equation. So here's the equation. 6n plus 7 is equal to 37. And so here's the replacement set, some suggested values that we're going to plug into our equation. So I like this handy chart. What we're going to do is we can write our possible n values down in a column and then write the equation and write up to, write or substitute rather, pardon me for being tongue-tied, substitute these values for n into the equation and see if it makes our statement true or false. And so if we go down the list, simply put, we put 6 times the quantity of 3 plus 7 equals 37. Check that. Well, 6 times 3 is 18. 18 plus 7 is 25. So I recognize that this is not true because what I would be saying here is that 25 is equal to 37. And we can see that that's not true. So I would say that this is false. Continuing on. So we've got this here. I'm just going to plug everything in and I'm going to get started. So this is going to be 24 plus 7, which is 31 equals 37. No way. So again, we have another false one. Here we have 30 plus 7, which is going to give me 37. And yes, we've got a true statement. This guy's true. Let's try this one. 6 times 6 is 36. When I add 7 to 36, I'm going to get 42. And we know that that does not equal 37. 6 times 7 is 42, plus 7 more is going to give me 49. And finally, we see that that also doesn't work. So these last few are false. These last two are false, as was this one. Instead of doodle marks, let me write that in, false. And we see that we have one true statement. And this true statement is going to be the solution to our problem. Let's try another one. Here we have 5 times the quantity of x plus 2 is equal to 40. And our solution set, our replacement set is the same 3, 4, 5, 6, and 7. I'm going to do exactly the same thing, rewriting the expression with every possible value of the replacement set and then checking to see if it works out. 3 plus 2 is 5. 5 times 5 is 25. And clearly 25 does not equal 40. So we know that that is not a solution and that's false. Here 4 plus 2 is 6. There we go. 4 plus 2 is 6. 6 times 4 is 30. So we get 30 equaling 40? Not at all. Five times 7 is 35. So clearly this is not a solution either. And then 5 times 8, remember we're doing what's in the parentheses first. 5 times 6 plus 2, 8. 5 times 8 is 40. And we see that ding, 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 we've got one that works. 7 plus 2 is 9. When I multiply that by 5, I get 45. And we can see that that is not a solution either. So all of these are false, except for when we choose x equaling 6, and that's true. So what that tells me is that x does equal 6, and that would be the solution for our particular open sentence. Here in example 2, we're going to use order of operations. I told you we use this all the time to solve our equation. And we remember that the division line is considered, so our equation has numbers over here and a variable over here. So all we need to do is figure out what the variable is. So we're going to evaluate this and we'll get Q. Now remember, division sign is given as a, what did we say it was? It was kind of a grouping symbol. So in a sense, we could think of a grouping symbol like that. Do everything at the top, then everything at the bottom, then go and simplify as you need to. So let's deal with the numerator. The numerator has, we're still thinking about please excuse my dear Aunt Sally or PEMDAS, right? And when I look at this, I say, oh, well, I've got addition and multiplication. Which one comes first? Multiplication. So I'm going to multiply. So I'm going to end up with 13 plus 8 over 3 times the quantity of 5 minus 4. And keep going. 13 plus 8 is going to give me 21. And then in the denominator, I'm going to do what's in the parentheses first because that's what we do. So I'm considering this like a whole new bracket, and I'm going to start over again with my PEMDAS, do what's in parentheses. That's going to be 5 minus 4, which is 1. So I get 3 times 1, and so I end up with 21 over 3. Now, I know that I'm doing this step by step. I know sometimes you will move quicker than I do, and that's okay. But I would like you to at least make sure you can follow along with why I'm choosing to do what first. And so finally, we know that whatever this is equal to Q, and so we can say that Q is ultimately equal to 21 divided by 3 is 7. Here in example 3, we're actually dealing with an inequality. Remember, an inequality doesn't have an equal sign. We're going to be dealing with less than or greater than or less than or equal to, greater than or equal to, and rarely you'll see this guy over here, not equal to at all. But generally, when we're talking about inequalities, we're talking about these 4 values here, these 4 symbols that are being used. I'll highlight the ones that we generally use. All right, so let's check it out. So this is the same thing. We've got a replacement set for an inequality. Now things get a little bit more involved because inequalities don't generally have one specific answer as some of those equations that we've dealt with do. These will have a set of answers or a solution set. So let's see if we can find it. First, let's go ahead and rewrite this inequality, replacing it with all the members of the replacement set. So after dropping that down, I just need to see if it's true. Is 18 minus 7, which we know to be 11, less than 10? And the answer is no, and that's false, right? Because 11 is not less than 10. Is 18 minus 8, which is 10, less than 10? It's not less than 10, it's actually equal to 10. How about this one, 18 minus 9? Yes, that's 9, which is less than 10. Indeed, that is true. And here, 18 minus 10, which is 8, that also is less than 10. So we have more than one true statement here. 18 minus 11, you know what it is. It's 7. That's less than 10. And also over here, 18 minus 12, which is 6, is less than 10. So we have a lot of true statements, a lot more than before. So if I had to give a solution set, one solution set for y would be all y's. Well, I won't do it this way. We usually do it this way. But in this case, I'll do y is equal to the solution set of, the values will be 9, 10, 11, and 12. Not that these are the only values, but the only values given here that work. So I'm going to write that as a set of answers. So that's about it for this section on open sentences. Please make sure you let me know if you have any questions or if there's any concerns about things that we discuss, whether it be this kind of extensive vocabulary where I didn't write down definitions, but I wanted to give you an idea, or why we're doing something. Let me know. I look forward to talking to you soon. Please make sure you try the questions that we have, the assignment, and I will see you very soon. Take care. Bye.